Figure 1 shows a hollow cone with no base made of paper. The radius of the cone is 6 centimeters, check, and the height is 8 centimeters, also check. The paper is cut from A to O and opened to form the sector shown in figure 2, okay? The circular bottom of the edge of the cone figure 1 becomes the arc, okay? So this part becomes that part. In figure 2, the angle of the sector is theta radians. Calculate theta and the area of paper needed to make the cone. So here I think I'm going to actually start by finding the area first. So the area of a cone equals pi r l. In this case, pi, well, that's just going to be pi. R is 6 centimeters. And then L is going to be this length right there. So to find that, we'll do 6 squared plus 8 squared square rooted, Pythagorean theorem. And so this is going to be 36 plus 64, which is, I think, 100. Yep, square root of 100, which equals 10. So this length right there is 10. So area of the cone is 60 pi. Yep. So area of the paper needed to make the cone, 60 pi. Not too bad. And that's just a formula to know pi r l. If you want to derive it, you could derive it, I think, through calculus, but that'd be more of a pain than it's worth. Easier to memorize. So now we want to find theta. So what I'm going to do to find theta is I'm going to take the circle, and I'm going to look at, so this is the cone, this here, and this is the full circle there. So I'm going to look at it like as a ratio. So this angle right here, call that theta, and then this angle right here, that'll be 2 pi. And so that the ratio of those angles will be the same as the area of the cone to the area of the circle. So we're going to call this theta over 2 pi, which is a full circle of angles. And the area of the cone, we know, is going to be 60 pi, and the area of the circle will be pi r squared. So r then, in this case, is going to be this length right there. So this is L, that is L, and we know that L is 10. So this will be 10 squared, which will be 60 pi over 100 pi, 10 squared. So ignore the middle part now. That way we can make it easier for canceling. So 60 over 100 is the same as 6 over 10, which is the same as 3 over 5. Pi's will cancel, and we can rearrange this and find theta equals 6 pi over 5, which is, so let's see here. If this was just straight across, theta would be pi, so a little bit more than straight across is, yeah, maybe 6 pi over 5. I'm going to say that's a very viable, potential, possible answer for the value of theta. And so that's how I do this one. On to the second problem. Diagram shows sector OAB with center O. Okay, radius 11, makes sense. Angle AOB, okay. Yep, is alpha. Point C and D lie on OA and OB respectively. Arc CD has center O and radius 5. The area of the shaded region ABDC, okay, is equal to K times the area of the unshaded region OCD. Find K. Okay. So we have, so I'm going to find, first I'm going to write out what this says here. So this says area ABDC equals K times area OCD, okay? OCD. And we want to find out what this ratio is. So ABDC, this region, compared to that region. Okay. So the area of ABDC, I'm going to find the ratio of, okay. Interesting. So I'm going to find area ABDC. Nope, that looks terrible. BDC will equal area of OAB minus area OCD, which is also what we want to find that too. So we'll keep that in mind. So for area OAB, that's going to be pi r OAB squared times, we're going to do the ratio of the angle, which in this case is alpha, to the ratio of the angle of the full circle, which would be 2 pi. So alpha over 2 pi minus, and then we're going to do the same thing for OCD. Radius squared of OCD squared alpha over 2 pi. Okay, simplifying these things a little bit, we can get rid of some of the pi's. I know it's always tragic to lose pi, but we'll struggle on. And we know the radiuses, radii. Radius of OAD is 11. So we have 11 squared alpha over 2 minus 5 squared times 11 over 2. Simplifying this a little bit, we can pull out the, oh, there we go, alpha over 2. Pull out the alpha over 2, and we have 11 squared minus 5 squared, which is 121 minus 25, which is 96. We have 96 over 2 alpha, which is, 48? I think it's 48. 48 alpha. What did I just find? Oh, the area. Whoop, interesting. Okay, 48 alpha. I guess it's 48 alpha times centimeter squared. Seems good. Interesting that there's no pi's involved. There probably are pi's involved because there's probably some pi's involved in alpha. Okay, so now we got the alpha up there, find the k, and that is equal to, oh no, wait a sec. That's area ABCD. Now we need area OCD, check, which is, we already found it here, is 25, which is 5 squared, alpha over 2. Yep, 25, alpha over 2, pi is canceled, we're good. And therefore, we're going to come over, bring this guy down, because this is what we're actually trying to find. We're trying to find k. And therefore, we can plug things in here. Whoop, whoop. K equals A OCD over, nope. Yes. No. A, B, D, C over A, OCD. And I'm going to write the area of A, B, D, C, which right there. So we have 96 over 2 alpha over 25 over 2 alpha. 2's will cancel, alphas will cancel. We have 96 over 25 as our value for k. Okay, excellent. So now we got to find the second part. So perimeter of shaded region ABDC is equal to twice the perimeter of the unshaded region OCD. Find the value of alpha. Okay, we can do this. We can do this. So perimeter ABDC. It feels so weird saying that. It should be ABCD. I know, not important, but it bothers me greatly. Okay, so we have perimeter OCD. And we need to find the exact value of alpha. So perimeter ABDC will just be this loop right here. So we know this part here is 5, this part there is 6, and we'll find this arc length by basically finding it as a ratio of the full circle. So the way to think of it is the perimeter of a circle is 2 pi r, and then we're going to compare that to as a ratio for the length of the full circle. So our arc is only theta long, but a full circle is 2 pi. See the 2 pi cancel, and therefore our arc length is just going to be r theta. That's something you probably know already, but if you don't, this is the way I kind of justify it to myself. So an arc length is r times theta. So for perimeter of ABDC, we're going to start here. We're going to be 6. We do 6 plus r, which in this case is 11 times alpha, so plus 11 alpha, plus another 6 going down the other side. And then we'll have this arc length here, which is 5, because that's the radius, times alpha. Simplifying this, and we have 12 plus 17 alpha. No, 16 alpha. Good catch. Good catch. So perimeter OAC now, we're going to start on the left side. So here, that will be a radius, nope, that'll be just 5. 5 plus this arc length here, which would be 5 alpha. 5 alpha. Plus another 5, and then plus 0 for the arc length on the bottom. You can think of it as 0 times alpha, because the radius for that part will be 0. Simplifying this, we have 10 plus 5 alpha. We are given the information here that the perimeter of the second half is twice the perimeter of the first half. And so we can use that equation. So we have this, we have that. We have 12 plus 6 alpha equals 2 times 10 plus 5 alpha. We have 20 plus 10 alpha. Write this again just for clarity. Right there. Okay, so now moving things around using red, we'll have 4 alpha on this side, and we have, this feels wrong, negative 8 over here. So this is where I went wrong. Clear real quick. Let's get the pen. 16. There we go. So we have, change this up real quick. So we have 16 alpha over here. So we have 6 alpha equals 20 minus 12, which will be 8. And then we have alpha equals 8 over 6, which is 4/3. So alpha equals 4/3 radians. Make sure that makes sense real quick. So 4/3 radians. So this looks about 90 degrees. 90 degrees is pi over 2, which is about, let's say 1.6. 4/3 is about 1.3. So yeah, maybe. That seems reasonable. So I know the picture is probably not drawn to scale, but it might be close, and it looks kind of close. So yeah, I would say that alpha equals 4/3 is a reasonable answer. So that's how I would approach that problem. Hope it helped a little bit. See you next time.